All right, calculus kids, here comes section 2.7. These are derivative rules for cosine, sine, and e to the x and ln of x. It might be time for you to start thinking of making a note card or getting just some kind of piece of paper where you have all these rules written so you can look them up if you get confused. But here's some you would want to have on your card. You'd want the power rule. Remember the power rule, I'll put it up at the top here. If I have a function f of x is x to the n power, for the derivative of that, the n comes down in front, x gets taken to 1 less power. Now we know that one. That would be something you'd want to put on your card. Here's another one for your card. If you take the derivative of cosine, it's negative sine. If you take the derivative of sine, it's cosine. So sine is a positive cosine, cosine is a negative sine. That's going to be a confusing point for a while, so you want to maybe have that so you have a reference sheet that you can go back to and look at. So they start out with just a couple examples looking at sines and cosines. So here's the first one. If you have 2 sine of x minus 5 cosine of x, all you need to do, just as if it's a polynomial, which it is, you are going to take this guy and you're going to take the derivative of each piece. So you've got 2 sine of x. Well, sine of x is cosine, so 2 cosine of x. Any coefficient in front is just a constant that stays in front. If I have a negative 5 cosine of x, well, that's a negative sine. Negative negative makes it plus, so you've got plus 5 sine of x. And there you go. You've applied the rules for derivatives with sines and cosines. Here's some rules that he reminded you of in the video. The natural log of 1 is 0. The natural log of 0 doesn't exist. Remember, here's the natural log graph. You're never going to have a value of 0. Doesn't hit it. E to the 0, anything to the 0 is 1. E's and ln's undo each other. They're inverses of each other, so your answer is just A. E's and ln's, same thing, undo each other, so your answer is just an A. And the other one that comes up in one of the problems in just a second is that the ln of E is equal to 1. Okay? So there's some rules for natural logarithms. Here is the rule, again, something for your note card. The derivative of something to the x power, an exponent, is a to the x times the natural log of a, whatever that base is. The derivative of e to the x, following the same thing, is e to the x times the natural log of e. Well, the natural log of e we just said was 1, and so it is just e to the x. It's really kind of cool. It comes up over and over again, but the only function who has its own derivative, the derivative and the integral, the derivative and the original function are the same, is your e to the x function. The derivative of e to the x is e to the x. The integral of e to the x is e to the x. Lovely stuff. All right, so find this guy, 2 to the x plus 3 e to the x. Well, 2 to the x is following this. 2 to the x, ln of 2. There it is. 3 e to the x is a 3 e to the x. Another one for your card is if you have logarithms, log logarithms. Log logarithms give you something like this. The derivative would be 1 over x, the number in this place, times the 1 over the ln of the base. If you're talking about ln's, natural logarithms, because this term in the middle becomes a 1 over 1, it's just 1 over x. So for natural log, maybe if I write it a little clearer from what he said here, d over dx, the derivative of the ln of x is 1 over x. That's what he's trying to say in the midst of that. All right, some quick examples. Applying the rules. If the function is 2 sine of x plus 5 e to the x, your derivative is 2 cosine of x plus 5 e to the x. Number 2 applies this rule right here. So you've got 3 to the x. Actually, no, it doesn't. It's the one up above that. Oh, can you see it all? Yeah, you can here. 3 to the x would be like this guy, 3 to the x. 3 to the x, ln of 3. Here it is. Minus 4 cosine of x. That does a double negative on you because it is a negative sign. So it's going to be plus 4 sine of x. Log base 2 of x. Log base 2 of x, that's this guy. 1 over x times 1 over the ln of 2. 1 over x times 1 over the ln of 2. and then I have minus a cosine of x. Then I just put these together as a single fraction, and that's my final answer. And again, these were on the video that he did, so we're just kind of quick going through them. Two more from his. Find the value of the derivative at the given point. Well, the derivative, find the value of the derivative at the given point, this is 5. So find the derivative first. 3 ln of x is 3 times 1 over x plus e to the x, and then plug a 5 in for the x's. There you go. Done. For number 5, you have 3 cosine of x. That's going to be a negative 3 sine of x. This would be like 1/2 the sine of x. So it's 1/2, and then the derivative of sine is cosine. But then you want to evaluate it at pi. Ooh. Go to the unit circle, figure out the coordinate at pi. It's negative 1, 0. Y is your sine, x is your cosine. So plugging in a pi, it looks like this. The sine of pi is your y, that's 0. Cosine of pi is your x, that's negative 1. And then you work out your details. This would be 0. This would be a negative 1/2, and that's your answer. Okay, so then let's look at some example problems together. There's only a few that I want to do with you because really the rules are pretty straightforward. First one is number 8. All of these in the first set from 1 through 10 are find the derivative. Again, you've got all those rules. Hopefully you wrote them down on a note card or a piece of paper so you can go back and refer. All right, here goes. Log base 7 of x. So I think about my logarithm rules. Here's my log rule right here. Log base 7 of x is going to be 1 over x times 1 over the ln of 7. So that's what I'm putting here. F prime of x is 1 over x times 1 over the ln of 7. And then I have plus the derivative of cosine. Well, the derivative of cosine, again, I'm going back and referring, derivative of cosine is a negative sign. So it's going to actually not be a plus, right? It's going to be a minus because the negative comes in, and it's going to be the sine of x. And so I can make that look just a tad better by combining that first set of fractions, 1 over x ln of 7 minus the sine of x. So all of those in the first 10 are just using the rules that they showed you on that front page to figure out those derivatives. Then they step up their game with number 13. He's next on my list. And they say, all right, find the value of the derivative at the given point. Okay, so now you're given a point. So not only do you have to take it to this step, but now you got to plug in what x is. In our case, in 13, our x is going to be a 0. So here it is. Find the derivative first, f prime of x. If I have a 4 e to the x, remember e to the x, the easy guy, he's just 4 e to the x. It doesn't change. Derivative of sine is cosine. This is going to be plus 5 cosine of x. All right, then plug in your 0. So here we go. If I plug in f prime of 0, I'm going to have 4e to the 0 plus 5 cosine of 0. If I'm at 0, I've got to figure out what coordinate that is on the unit circle. 0 gives me the coordinate 1, 0. Right, that's the very beginning of your unit circle. So e to the 0 is 1. This first piece gives me 4 times 1. The second piece gives me 5 times the cosine of 0 is the x value. So I get 5 times 1, and so 4 plus 5 gives me a value of 9, and that's number 13. All right, next is number 15, where they change the directions again on us. And for number 15, now I'm looking at find the equation of the tangent line at the given point. Well, if I want to know what the tangent line is, I need a slope, a derivative, and I need a point. So let's go with slope in first. F prime of x, find the derivative. 3 cosine of x, remember the cosine of x is going to be a negative sign. So I'm going to take a negative 3, it's going to be a negative 3 sine of x. And the derivative of x is 1. You're taking whatever the coefficient is whenever you have just an x value. But I want to know what it is at pi over 2. So f prime of pi over 2 would be this, negative 3 sine of pi over 2 plus 1. So I have to think again about the unit circle. There's a whole lot of questions about the unit circle on this particular packet of notes. If I'm at pi over 2 on my unit circle and I go around and I think, all right, pi over 2 is up at 90 degrees. What's the coordinate there? Coordinate is 0, 1. So I have a negative 3. The sine of pi over 2 is the y value times 1 plus 1 gives me negative 3 plus 1, or negative 2. There's my slope. But I also need a point, and my point comes from taking pi over 2, the x value, and plugging it into the original equation, 3 cosine of pi over 2 plus pi over 2. Well, cosine of pi over 2 is the x value, that's 0. So this whole thing becomes a 0 plus pi over 2 is pi over 2. Now I have a slope and I have a point, and I can put it together for the tangent line, not the normal line, tangent line. Y minus pi over 2, this pi over 2, equals my slope of negative 2 times x minus pi over 2. Done. All right, so the procedure is still the same, it's just they're giving you more complicated functions to work with now that you know more rules for the derivatives. All right, last one. Number 22. Number 22 says a function f of x is equal to x plus a cosine of x, where a is a positive constant somewhere between 0 and 2 pi. So it's got to be positive, which means a has to be greater than 0. Find the x coordinates of all points between 0 and 2 pi where the line y equals x plus a is tangent to the graph of f of x. So this is kind of like questions we did back in the last section, last couple sections anyway. And what really we want to check out is what's the continuity doing? And we want to figure out what the derivatives are doing. All right, so I'm going to figure out where they're equal to one another. What are the places where these would be equal? So continuity means take the original function, the original functions, and set them equal to one another and see what you got going on. So I'm taking x plus a cosine of x is supposed to equal x plus a. And you look at that and you're like, what on earth? What am I supposed to do with that? But hopefully somebody in the hood might realize that when you put these together, your x's are going to cancel, right? If I bring this x to the other side, it's going to subtract out with that guy. And I'm left with a cosine of x equals a. And you're like, I can solve for cosine. I can do that now. Because the cosine of x is going to be a divided by a, or 1. And you're like, oh, wow, that's really cool. Cosine of x equals 1. I can go around my unit circle and figure out between 0 and 2 pi where that happens. So, where is the x value, cosine, 1, looking at your unit circle? In the first place it's 1 is at 0, because the coordinate's 1, 0. And the only other place, because it's equal to 2 pi, is also at 2 pi. Because those inequalities include that 2 pi, you're going to put that as your answer too. So there you go. That's first piece. Comes out nicer than you think. Second piece is check out the derivatives of these guys. So the derivative of f of x is 1, and then it's cosine, derivative of cosine, so that's going to be negative sine. The constant in front just stays the constant in front. So 1 minus a sine of x is my derivative for the f of x function. And my derivative for this function over here for the line is just 1. Right? Because the derivative of a is a constant, so that's 0. So here's where I'm at now. So I'm looking at this and I'm wondering, do the 1's cancel each other out again? So I've got, if I subtract 1 from both sides, now I have negative a sine of x equals 0. And when I divide by the a to get the sine by itself, I get 0 divided by a negative a, and that's still 0. So now I want to go around my unit circle and figure out where is the y value 0. The y value is 0 at 0, It's also 0 over at pi because the coordinate at pi is -1, 0. And then when I close up my unit circle, closing at 2 pi because that's where they said to stop, is this. And so the answer to the question is find the x-coordinates of all points between 0 and 2 pi where it is actually tangent to the graph of f of x. And so you're taking where they both, answers what they both have, what they have in common. What they both have in common. And that would be at 0 and 2 pi. You would not include the pi because pi wasn't part of this guy. It has to be part of both guys for you to be able to say that that's where it would have that tangent line. All right, so that takes care of section 2.7, and I will see you in class. Email me if you have questions. See ya.